Okay, I'm going to work through a couple examples from worksheet 7.4b, two-column proofs with quadrilateral eye. So for this one, we have two triangles that are congruent to each other, and we know that GHJK is a parallelogram, and we want to prove that it's a rhombus. Now, in my figure, it looks like a square. That's not what we're trying to prove, and we don't know that it's a square just because it looks like one. What we do know is that it's a parallelogram, and we know that LGK is congruent to MGK. Since this is a parallelogram, it would be sufficient for me to prove that two adjacent sides are congruent to each other, which I can do using the fact that these two triangles are congruent to each other, and CP, CTC. Congruent parts, corresponding parts of congruent triangles are congruent. So first I do my given. I'm just going to circle it and put it down there. You should write it. Then I'm going to say that KG is congruent to KJ by CP, CTC. And then I'm going to say that GHJK is a rhombus. And that is a parallelogram with adjacent congruent sides is a rhombus. You got to write the whole thing out because that's the reason. We don't have a shortcut. Okay, that's that proof. We're also going to look at number 6. So in this, we have this parallelogram, B, BC, GH, and then we know that this entire side is congruent to this entire side. That's very helpful because this is a triangle. It's an isosceles triangle that's been knocked over onto its side, making this angle congruent to this angle because of the base angle theorem. Now, why might that be helpful? It's helpful because I'm trying to prove that F, there's F, is congruent to GCB. Now, I already have a way of proving H is congruent to F. Do I have a way of proving that H is congruent to GCB? Why, yes I do. And it's the fact that that's a parallelogram. So remember, in a parallelogram, opposite angles are congruent. So this is a pretty short proof too. I'm going to start with my given. Write it in. I'm not, to save time. 2. We're going to say that angle H is congruent to angle F, and that is the base angle theorem. Then we're going to say that angle H is congruent to angle GCB, and that is opposite angles in a parallelogram, gotta write it out, are congruent. It's not the definition of parallelogram. That's not the definition. Definition is opposite sides are parallel. That is something that we have shown to be true. Now we have H congruent to F, H congruent to GCB. So therefore, using transitive, we can say angle F is congruent to angle GCB. And that's transitive POC. Another quick two-column proof. All right, good luck with the rest of your homework.